right. For, gentlemen, ladies. For number 1 and 2, how did I get y1 and y2? Substitute. What am I substituting in? X and x. So this is x1, x2. Some of us forgot how to do that. And then I just used what to find the rate of change? What do I use to find the rate of change? What do I use to find the rate of change? I use something. Should I cold call? I think I'll cold call. Let me find my wheel of possibilities. I think that's what I'm going to call it. Thanks for laughing. All right, wheel of possibilities. You can't see it, but I can. We're going to go green. Nope, it's purple 2. Where's purple? Where's 2? Is there a purple 2? No, so then purple 1. Who's purple 1? Okay, what do I use to find my rate of change after I find my y's? You don't know. Here's the problem. We're just sitting here not asking questions. Let's go. Orange. Nope, sorry, blue 1. Do we have a blue 1? Blue 2. What do we use to find the rate of change? Very good. What is this called, Anthony? You forgot what's this called. What is this called? Anybody? If we don't know, look back at our notes from Thursday. It starts with an S. Slope formula. This is the slope formula. So, Alex, because you don't know, make sure you write this down and write down slope formula. And for those of you who don't know, make sure you're writing this down because I think we're going to be cold calling a lot more. Are there any questions? So if you don't have this down, make sure you write it down. Here are the answers, -4/3 and +72. Those are your answers. Questions? Are we sure? Are we sure? Because once we start doing the problems in our practice, if I have to answer the same question over and over again, I'm going to say, you had no questions. Can I go down? All right. Here are your answers for the next 2 problems, 3 and 4. 3 and 4. How or what is given to me? What values are given to me in these problems? Your x's. How do I find my y's? Not your question. How do I find the y's? Louder?
They're next to the x.
They're next to the x. What is that called? What is the x and the y called? A point? What else would it be called? Starts with a C. Coordinate. These are the coordinates on the graph. Make sure you're using the correct ones. After I find my coordinates, what do I do to find the rate of change? After I find my coordinates, what do I do to find the rate of change? do I use? Slope formula. Again, you have your x1, x2, y1, y2 substituted in, and you're done. Are there any questions? Are we sure?
Yeah.
All right, when you're done writing that down, flip over. We're going to do level 2 examples today. We're going to do level 2 examples today. While you're still writing that down, for those of you who are writing it down, level 2 examples have to do with word problems. Word problems. So we're going to need to make sure we understand what the word problem is giving, what we need to find, and what it's asking us. Okay? Can I move this? Okay. They're going to be, so we don't have regular notes today. Hold on. Give me a second. We're just going to move on using the same notes from last week. We're still going to be using the slope formula. We're still going to be needing to find the y values for some of the problems. Okay. For all of these problems, these are word problems. You're going to need a few things for the word problems. You're going to need to show your work for the word problems. That includes substitution. That includes showing me your y2 minus y1 divided by x2 minus x1. And it does not matter if you got every single rate of change right. If you do not include units or an explanation in words or a fraction, you will not receive full credit. It does not matter if all of them are correct. You will not get that 2. You'll get a 1.5. When we do 3s, you won't get that 3. You'll get a 2.5. Got it? You need to include units. What do I need? Or what do you need to get full credit? Show your work and include your units. Okay, let's start with the first one. It says below is a graph of the temperature of an object flying to the sun to measure temperature. Find the average rate of change between the first and 5th hours of the object. Okay, what information did they give us that we need to find? First and 5th hour. First and 5th hour are what variable? Why? What is the bottom of the graph called? X-axis. So this is the x-axis, which means that these are going to be your x's. So x1, x2. Questions? Are we sure? Okay. So how do I find my y's? How do I find the y coordinate for it? How do I find the y? Not trick question. Let's call on green 2. Who's green 2? Is it Wendy? How do I find the y coordinate? On the graph. Okay. What is the units for the y? Specifically. Don't know? All right. Let's see. We're going to go yellow 2. Specifically, what are the units? Who's yellow 2? So Uriel said that it is temperature, but what specifically are they?
Fahrenheit.
Yeah, Fahrenheit. Degrees Fahrenheit is going to be my units for the y. Okay? So we have 1 and 700 and what? What's my other coordinate? 5 and 1,640. Good. Okay? Excuse me. What am I going to use to find the rate of change? Slope formula. So it's going to be 1,640 minus 700 divided by 5 minus 1. Let me write these in. So we have 1 hour, 700 degrees Fahrenheit. Make sure you're writing this down so you know the units. Divided by 5 hours, 1,640 degrees Fahrenheit. So before I calculate this, we've already said it. Let's see if we can remember. What are the units of my y values? What are the units of the y values? Degrees Fahrenheit. What is the units of my x values? Hours. Okay? Questions? So when I put this into my calculator, I get 235. Would you get full credit for this? No. What you need to do is include your units. So this is why I include my units as a fraction next to my slope, because I can then write it as 235 degrees Fahrenheit per hour. Sorry, that should say degrees, not an of. Or you can write it in words as 235 degrees Fahrenheit per hour. So either one of these would work. Are there any questions? Are we sure? All right, does everybody have that down? Okay, let's look at number 2 then. Number 2 says an astronaut drops off a rock off the cliff of the edge. I can't talk today. A rock off the edge of a cliff on the moon. The distance, d of t in meters, the rock travels after t seconds can be modeled by the function d of t equals 0.8 t squared. What is the average speed in meters per second of the rock, bless you, between 5 and 10 seconds? There is a 3-word phrase that gives me the unit already, or the rate. Does anybody know what that 3-word phrase is? Angie? Very good, meters per second. So this is my units and my rates. Good job. These are my units. Meters will go in the numerator. This word per implies division. Second. So this will help you determine what is your y and what is your x. This will help you determine what is your y and what is your x. So let's start with my denominator, seconds. We need to create 2 coordinates. What are my x values? What are my x values? Jesus, what are my x values? 5 and 10, very good. 5 and 10. Good, good, good. Miguel, how do I find my y values then? Can't hear you. Don't look to Anthony. How do I find my y values? Hint. It's like questions 1 and 2 on the do now. Look at us flip over. Kimberly, how do I find my y values? No, that would be in my slope formula. I don't have my y values. Sam?
There's like a question put it plug it into the DT.
Yes. We need to substitute in the x values into this equation. Substitute in the x values into the equation. So the first one, so y1 is 0.8 times 5 squared. That will give you 20. How do I find y2 then, Sam?
Do the same thing, but instead of 5 is 10.
Very good. Substitute in 10. And when you do that, that's 80. What are the units for the x values? Seconds. What are the units for the y values? Meters. Just so you know, seniors, this right here is going to be your y, and this right here will be your x. In a phrase, this is your y, this is your x, because remember, your slope or your rate is always your y over your x, the change of y over the change of x. Remember that delta? Delta y over delta x. So now that I have my coordinate pair, what do I do? Slope formula, good. So we have 80 minus 20 over 10 minus 5, and that gives you 12. Would you get full credit? No, what are you missing? Units. So you could put 12 meters per second, or you can write it 12 meters per second, or, am I off screen? 12 meters per second. Okay, any of these three things will count. Any of those three. Questions? Are we sure? You sure? Okay. All right, let me scroll up. Can I go right there? Number 3, on a road trip, after picking up your friend who lives 10 miles away, you decide to record your distance from home over time. Find your average speed over the first 6 hours. Okay, so how do I know in this table what my x's are and what my y's are? And don't say it's always the top, always the bottom. I need specifics. I need specifics. There is one thing in this chart that tells me what my y is. Does anybody know? It's okay if we don't. D of t. This is a function. This is like f of x. And f of x is also equal to what? Y. F of x is always equal to y. Sam, you're on a fire today. F of x is always equal to y. So whenever you see a table, and you will get one like this on your quiz tomorrow. When is your quiz? When is your quiz? Tomorrow. So I don't want to hear that you didn't know I had a quiz. Let me go. We have a quiz tomorrow. We have a quiz tomorrow. Okay? We have a quiz tomorrow. So if this is my y, what is ours? X. Very good. Here's x, here's y. Don't always say it's always the top. It's always the bottom. No, I will. Okay, I will mix it up. Okay, make sure you know that when you have function notation, that is your y. Cool. What are my x's then? What are the x's I'm looking for in this problem? Oscar, what's one x I'm looking for in this problem? 6. So here's my x. What is the y that goes with it? 292. Very good. So we'll label this x2, y2. 6 hours. Diana, what is the other x I'm looking for? If it's the first 6 hours.
What?
No, and that is what students always think. That's okay. Milka. 0. 0. We need 0 because we need to know when we start, and we start at 0 hours. Does that make sense? Okay? I know some of you were also thinking 1. So make sure when it says first 6 hours, you start at 0. So that's going to be x1, y1. Okay. What? So we have the change. I think I'm going to start using this. The change of y over the change of x. What are the units for y? Miles. What are the units for x? Hours. Good. So when we write our final answer, we should have something that says miles per hour. All right, Diego, what should go in my numerator for slope? What should go in my numerator for slope? $292. Very good. 292 minus 10. Crystal, what should go in my denominator? Six minus, can't hear. Minus 0. We put this into the calculator and you get 47. Is that the final answer? Why? You need units. What are my units? Miles per hour. Questions? Yeah.
Can we do the same thing we did for the first person? Can we just put like
Yeah, you can put miles per hour. Make sure you're putting MI because when we use M, that's meters. Okay? Questions? Diego, sit up. Thank you. Do you need to go get water? Questions? Are we sure? Because when we have you do your examples, I'm going to make you refer to all of these examples right here. All right. Then grab your practice sheet. Did I pass out the practice sheet?
Yeah.
Okay.